Hello everyone and welcome to Java Basics. Today we will continue our adventure into Spring Boot by building a simple Wordle web service on top of the Spring Boot application we created last time. This is the code from 2 videos ago. You can reference back to it to understand where I got some of the concepts from. Today's code is in this URL. It is in the same URL from the last time since both of these videos are in the same set. REST stands for Representational State Transfer. It's an acronym that might tell you something later on, but it's really not crucial at this point. The main thing you need to understand about REST is this. We can use it to invoke a remote feature. You know how we invoked a method and it did all sorts of work for us? What if I can invoke a method from a big company? I can ask Google about street addresses. I can ask Facebook about my social graph. This is the idea behind a web service. We can use the HTTP protocol, which we use every day, as if it was a method invocation. We can use JSON to get responses. This is a big idea with many subtle complexities. I won't get into them. We'll just build something and you'll see how it works. We start with the Spring Boot project we built last time. We expand the src directory. Notice the main method, the initializer created for us. It just sets up Spring and finishes. This is a complex concept. I won't go into this time around. It doesn't seem complex since it's just one line of code, but the implications are elaborate. Typically, we don't create web services in the application package, so I'll create the web service in a new dedicated package for it. Notice that for Spring to detect your code, it needs to be under the main package. So all the packages in this application must be under com.debugagent.wordle. I type in the name and press enter. A new subpackage is created. We create a new class which will implement the web service. We name it with WS at the end, although this isn't necessary. It's just a habit. I start by adding an annotation to the class called REST controller. An annotation is a special syntax in Java that lets us provide hints about an element in Java. Annotations might be relevant in runtime or compile time. In this case, the annotation tells Spring that this class implements a REST API and it would treat it as such. Here's the interesting part. I create a new method that returns a string. This will be used by the user to guess the word similarly to our command line application. Here I add the get mapping annotation and give it a relative URL, guess. When you visit the website, it uses the HTTP protocol to process your request. The protocol is a communication language between both sides. So your browser sends the string get and guess. Then it will get back the content of the website. Notice that this is oversimplification and no longer works exactly like this. But the basic idea is true. HTTP has methods of its own, not to be confused with Java methods. The most basic method is get, and that's what your browser uses to fetch a page. Here we implement this get method, and we also accept an argument to that get, an argument named word. Let's rerun and go into the browser to see how this works. The original hello world works as before, but we can now type in guess and give it a parameter using the question mark notation. This is called a get request, and notice that the result adapted to our request and returned a string as expected. The word using was passed to the code and it was able to make use of it. Let's do the same for Wordle. This is the code that's practically copied and pasted from the previous Wordle application, so I won't explain it too much. But notice that I made the dictionary final and initialized it here. The reason I did it this way is simple. The previous demo had a main class. It had a point where the application started and ended. A server runs all the time. It receives and processes requests, so we need to initialize the variables on start. There are better ways to initialize variables in Spring, and normally static variables are discouraged in Spring Boot. But for now, to keep things simple, I'll use a static initializer. The syntax looks a bit weird. The word static followed by the curly braces scope, but it runs when the class loads and lets us initialize static variables. We're reading from a stream, so we use try with resources to catch the error and close the stream once we're done. I could use the code from the previous application, but it would be considered a bad practice. In server applications, we often want everything to be in a single package. So I want the word list in the main application package, not in an external file. This matters since at some point I will need to copy the server application to an actual physical machine in the cloud. If I make a mistake and only copy one file, this can cause a problem. If the file is packaged in the application, I need to access it using a different API. ClassPathResource is a Spring API that lets me fetch a file from the resources directory and turn it into a stream. Now we just need to read that stream. The scanner API, which we use to read the user input, can also be used to read the stream here. We define /n as the delimiter. /n is the new line character. That means that the code will read strings, and every time there's a new line, it will move to the next string. Then we just use a loop to read in all the strings one by one. Notice that I use the toUpperCase method, which means all the strings are now uppercase. Finally, since reading the input stream throws a checked exception, this won't compile. We need to catch the IR exception. The problem is, what do we do with it? I can print an error, but if we can't read the file, this is a fatal exception. We would want to exit the application. If only we could just let the exception continue, it would crash the application and exit. Unfortunately, this won't compile. A runtime exception can be thrown anywhere in Java. We can use the throw keyword to throw a new runtime exception. As an argument, we pass the existing IR exception. This means that if reading will fail, we will see the IR exception in the error log, and we would understand the problem. An exception in Java unwinds the stack. Let's explain throw with an example. Let's say I have method A that calls method B. It doesn't matter if it's in the same class or a different class. This will act the same either way. When we invoke a different method, what happens to the variables we define within the body of method A? Say in this example, we have both the arg argument and the val within the method. These are called stack variables. They are visible only within the method itself. So what happens to them while we're within method B? Each method is a part of a stack frame. This is a term you might have noticed when we talked about the debugger. Every time we invoke a method, the frame of the current method gets pushed into the stack, and then we return from the method. When we return from the method, the stack unwinds. That way, we get back the variables we had before. This goes on and on. We can invoke method C, and then its variables get pushed into the stack, and the same happens again. We invoke method D, which results in the same effect. So far, so good. When we return from method D, the stack will pop the last frame. But what happens when we throw an exception? What if our catch statement is in method A? The exception will jump all the way back to the catch statement of method A, but it will clean up nicely behind itself. All the stack elements will rewind. This is pretty powerful. We don't need to write error handling code all over the place. We can just throw an exception and trust that someone along the way will do that for us. Everything will be cleaned up and returned to normal. Going back to the code, we now have the variables needed by the Guess web service. Let's start implementing it. First, we delete the existing code. This code should be pretty familiar from the previous Wordle version. If the word is of a bad length, we'll return an error that the length is incorrect. To look for the word in the dictionary, we first need to make sure it's in uppercase. Now we can just use the contains method like we did before. If the word isn't in the dictionary, we can return the appropriate error message. And this is the exact loop over the characters in the word that we had in the previous Wordle app. We loop over all the characters and compare them to the actual character that should appear in place. If the character is exactly the same, we add a G to represent green to the result string. If you recall the previous version of this application, we printed out the letter G. Here we do the exact same thing by appending G to the string. We do the same thing for yellow and black, just like we did in the previous application, only instead of printing, we add the letters to the string. We then return the result, and with this, we're almost ready to test out our work and see if we have everything in order. But there's just one more thing to do. I'm going to the old Wordle project and copying the word.txt file from the root directory. This is a standard Command-C or Control-C. Then I paste it in the resources directory. This will repackage it with the rest of the application as a single bundle and will make it available to our resource reading code from before. With this, we're ready to launch in the browser. Reloading and then changing the word quickly shows that this indeed works exactly as we would expect. But this isn't a proper REST API. It returns a string. We need to return JSON. How does one do that? We start by creating a new enum called character result. An enum is a special type of class in Java. We can use it to have several types of values. This is best shown with an example. Inside the enum declaration, we create the individual values for the enum. These are the instances of the enum. We can't allocate more and can't invoke a new enum. This enum has 3 instances: green, yellow, and black. These are all checked by the compiler. Instead of writing the letter G, we can just write green, which is more readable. We can't make typos like typing the letter F by mistake. Now, to create the JSON, we can create a new record. We add 2 properties to the record. One is an array of the character result enum. This will represent the value for each one of the letters. The second value is the error message, which will be null if there's no error. This way, we can easily differentiate between the good result and an error message. Now let's go back to the method and fix the code to use this new class. I first update the return value. This instantly marks all the problems in the code that I need to fix. All the strings I returned should now return the result object. This is easy. We can return null for the array since there is no valid return and just return the error message string like before. We'll soon see how this maps into JSON return value. Instead of the string, we create the array of the characters that we will pass to the result constructor. I can create an array of 5 elements. but this is generally a bad practice in programming. I use the length of the word, so if tomorrow we want to create 6 or 7 character Wordle, this will work seamlessly. We now replace all the character arithmetic with assigning an enum value to the appropriate array position. This is cleaner code, as the Java compiler will verify the assignment. We now create a new result object and pass a null error message, since the array should contain the applicable details. This was all a bit abstract. Let's restart the server and go back to the browser to see why this is so great. Once we reload, we can see that JSON is organized more cleanly. Every result has a place in the array and a descriptive color. When an error occurs, it's instantly clear that this is an error, as the object looks different. Since this is JSON, we can switch modes in the browser and see the raw JSON, which we can also pretty print. Notice that in the code, we didn't write any JSON. This was all done seamlessly by Spring. It grabbed the HTTP request, converted the object to JSON, etc. It's a very powerful framework. This was a long video that covered a lot. Next time around, we will start covering this, converting this to a web interface. If you have any questions, please use the comment section. Thank you.